I'm Sunil. I work as a blockchain solution architect for one of the leading MNC. First module into what we will look is we will look into what is this cryptocurrency, what is blockchain. People are talking about what is this blockchain all about. We are going to look at those concepts and we are going to touch base on a couple of currencies. Especially we will take Bitcoin as an example and then the entire module, right? It's all from Bitcoin. Once you understand Bitcoin, then you understand blockchain. This module will give an idea about it. So here first, we'll see like how the trading happened since old age. So first it was a barter system. Barter system is you give a product, in exchange you get another type of goods. So that's how things were, and then things moved on to gold coins, then that became expensive, and then we came to fiat money, online banking, digital money, and bitcoins. Okay. And I'll give a simple example what happened with the system. Now I'm going to talk about barter system. Barter system is nothing but we exchange commodity. There is no currency as such, we just exchange commodity to get another type of goods. So let's take in a community there are three type of people. So one is chicken grower, so other one is rice producer, and third one is a heart specialist. So these three community people live in a society. And what happens is, so chicken grower wants to sell chickens. Similarly, everyone does their job and in return they all need to exchange goods to get something out of it. Now what happens is, rice grower says 1 kg of rice costs you 10 chickens. Then now chicken grower has no choice. So he has to give 10 chickens and get 1 kg of rice. If 1 kg of rice costs him 9.5 chickens, is this possible? It's not possible, right? So either you'll have to kill the chicken, give half, then it's not going to make any value. At least, if you have a whole chicken, that has something. So there is a problem with that. We are going to see like what all problems we had in the barter system. First one is divisibility. So you're not able to divide chickens. Okay, you see your commodity, it's not dividable. Suppose if you want only half kg of rice, half kg, okay, you can get 5 chickens. Suppose if you want a quarter kg of rice, then it's not possible, right? So you need to give 2.5 chickens. So there was a divisibility problem. So another problem was durability. Durability is nothing but how long these chickens are going to last. Suppose say, let's assume that there was bird flu and all of your chickens died. So in your community, you're left out with nothing. So you cannot survive at all. So this is durability problem. Perishable goods, it's going to perish in a while. So the next one is, let's go to verifiability and then fungibility. So next is verifiability. So no two chickens are same. So chicken 1 and chicken 2 may be totally different and it might have some disease. Chicken 1 might have a disease and chicken 2 is hale and healthy. So as a rice grower, he will not be able to distinguish which chicken is good and which is not good. So here is a verifiability problem. Okay, so the last one is fungibility. Fungibility is nothing but, so if you suppose this heart specialist, he says that in your old age, he claims to the community that if in your old age or any time in your life, if you have an heart issue, I'm going to address it and I'll do that, and please give me 10 chickens or give me like kg of rice until then. And rice grower and chicken grower thinks like, I'm hale and healthy, nothing is going to happen to me. Why should I pay you upfront cost? I'm not going to do that. So then what happens is heart specialist, in spite of doing a lot of research and study and he possesses skills, he is not able to purchase rice or chicken out of it. So this is the fungibility problem. So to address all these came fiat currency. Fiat currency is nothing but our dollars and rupees. So now let's see whether this fiat currency addresses this problem. So if you have $1, it could be divided up to single cent. So your divisibility problem is solved. Durability. Until unless you throw the currency note, you are not handling it properly, it's going to stay forever. If you have a coin or currency notes, it's going to stay forever. So the third one is a fungibility problem. So fungibility, here what happens is heart specialist, he was not able to purchase anything. So instead what happens with the fiat currency? Okay, he charges a very lump sum amount at front if someone has a heart problem and he has this currency, and then he can go and use it. And verifiability. So verifiability is nothing but you have this 100 rupee or $100. Okay, you can go to Walmart or you can go to anywhere. So it's $100. Okay, until unless it is a fake currency, you can go everywhere it is verified because it is a legal tender issued by the government, and you can use it wherever possible. So that is the reason a fiat currency came into existence. So before that there was gold coins, and here also there was some history, but let's not go into that. So that's how fiat currency came into picture. Then what happened with the fiat currency? Then sometime back we started online banking. It was not all currency notes, it was all digital transactions. You have an app, you have mobile, you try to send digitally, okay, instead of you going meeting in person and giving some cash. Started doing online. Then came corporate tokens. So corporate tokens is nothing but, suppose if you go to Amazon, you do something and you purchase something, they give you a tokens. With these tokens, you can go to a restaurant and you can spend it. Or in India, you can look at something like Sodakso coupons. So these all things happens. Now we are in the age of Bitcoin or decentralized digital money. Before going into that, okay, I will tell you there is a problem with the fiat currency. Fiat currency, it is completely depends on the faith. You have faith in your government that your currency is going to do good. So, for example, in India, some time back, there was this demonetization. So it is nothing but one large currency. So it was completely 500s and thousands were completely scrapped. So then at that time, what happens? Even if you have ₹1,000,000, nothing could do nothing with that, right? Because it's all owned by the government. Or let us take another example. In 1984, one Zimbabwean dollar was equivalent to one US dollar. I'm not exactly sure about the year, I think 1994. And then what happened in 2004 or 2005, they'll have to give 500 million Zimbabwean dollars, which was equivalent to one US dollar. So what happened with Zimbabwe was they had this civil war and their government was not doing great. Okay, so internally there were some corruption and things like that, and their currency did not go well in the market or in the world. And would you say it is a problem with the Zimbabwean people? No, they believed in their government. They thought like they would be doing good, but their money value was completely down. Completely they were thrown off. Let us take an example of Afghanistan and other countries where we had this war. What happened? So suddenly your government is not doing good. There was a war threat. Some war had happened. Your currency completely got down due to external economic pressure. So if you look at the fiat currency, it's all like faith in the government. So that's how it's run. Now, when we move to Bitcoin, you would appreciate, how this faith is built on Bitcoin. Other than government, you're not using the government here, but how this is trusted and used by all the parties. So Bitcoin is the first ever digital cryptocurrency, which was created in 2009, and the underlying technology is called blockchain. In fact, when this Bitcoin was discovered or invented in the white paper, okay, in the white paper it was mentioned as chain of blocks. The technology which was used under that was called chain of blocks. What happened was eventually people started calling it as blockchain, and that's how we got this name blockchain. But it was all started from Bitcoin. So that's why Bitcoin and this blockchain is closely related, or you can see that when you go in for meetings or when you talk to people, they talk about Bitcoin whenever you talk about blockchain. So now let's understand what is blockchain. So blockchain is nothing but it contains some records or it contains some transactions which are stored as blocks. And important property is it cannot be tampered and it cannot be updated. For instance, let us say that, okay, let's take a simple example, okay, just for understanding purpose. Let's say take Samir has shared his Facebook post, okay. He has shared some posts and videos. So what I'm considering every share as a transaction. And then what happens is, so today whatever Samir has done, whatever has shared in his Facebook, those all I'm considering as a transaction. I'm adding this transaction into block. So I'm considering for each day I'm going to consider one block. So what happens is all this transaction goes here. This will be part of a block. And tomorrow some other transaction would happen. So that is another block. So here, and it goes on like this with time. And each of these transactions, right? So these transactions are cryptographically signed. We will look into that deeply. And each of them are chained. That is, every block will have something called hash and they are all tied together. Just imagine how you are connecting all the blocks. And the important thing is the first block which is created is called Genesis block. Suppose now Samir has done some transactions, right? He has shared some Facebook posts. So after 10 days, he thinks like he wants to change this transaction, or he feels that he shouldn't have shared or something like that have happened. Samir will not be in a position to go and change this. So that is actually blockchain. So these are blocks, one of the property of blockchain. So you cannot change it. Whatever you have shared is shared. So there is no way of getting back here and changing it. So that is not possible. So we will see one by one, like why we need such kind of blocks and transactions. And also remember, when you add these transactions in this block, whatever you have this block, it means that it is completely verified. It is verified, it is all the calculations were considered, and then only this is moved as a block. So it means that when you're going to attach the second block, you're rest assured that the first block was good one. It was not a tampered block, it's a good block. So this is how the blockchain industry is revolutioning. In fact, this all started before 2014. So they represented from 2017. So a lot of VCs are investing, a lot of industries. You can see that you can just type in blockchain and look for the news. It is like rage actually. A lot of people are getting into this field, especially since this cryptocurrency is closely involved with blockchain. Okay, so it has a like more of it. Like if you look at other technology, it doesn't have any financial incentives. But when it comes to blockchain, it is completely revolutionary. There is something called ICO, you might have knowing, initial coin offering. Previously, we heard the term only called IPO, initial public offer. So new coins are getting generated, new platforms are being developed. A lot of things are happening. What they're claiming is in 2023, it will be all consortiums. That is, a group of people would be work together to form a blockchain platform for a specific industry. Okay, so these all things would happen. And 2024 is when most of the systems you can see there is a blockchain adoption, many industries. And 25, it's all through, and they're claiming that it could be used, 85% people would be using blockchain technology. So this is an idea like how the government would be using. For example, if you see, we are all using these wearables, right? So the wearable devices, Fitbits, and other IoT devices. Okay, so these devices would start interacting with blockchain. So this is one of the biggest use case in the market right now, especially if someone from telecom background or core C++, C++, I think this would interest you. And many government related projects where they would create more transparency, okay, using this blockchain technology. Some of the examples, smart city, they're saying even there would be a 10% increase in the world GDP. So we'll look at how our current system works. Suppose, let's see, like today, if you want to transfer some amount of dollars from United States to India. So there is a Bank of America in United States and there is a State Bank of India bank in India. So you are trying to send $10,000. Let's say Pranav is transferring $10,000. What happens is from Bank of America, you are initiating a transaction. Then what happens is, so this is nothing but Federal Reserve. So similarly, India, there it is called Reserve Bank of India. Okay, and the local Indian bank is called State Bank. So now what happens? Pranav is trying to send $10,000. Internally, what will happen is this Federal Reserve will maintain how much Bank of America has. Bank of America in turn will maintain how much Pranav owns. Pranav has $10,000. Suppose, let's say Pranav has $20,000. And what will happen is now Pranav is trying to initiate a transaction of $10,000 to State Bank of India. What would happen is, first, this amount would be deducted from Bank of America. Okay, it notifies Federal Reserve that, okay, a $10,000 is going to be deficit from my Bank of America. So Federal Reserve reduces the amount Bank of America. Suppose Bank of America has $100,000. It reduces by $10,000 and it initiates a transaction of $10,000 to State Bank of India via Reserve Bank. Okay, it will be sending to Reserve Bank of India. And Reserve Bank of India finally transfers to State Bank of India, and State Bank of India finally deposits to Pranav's account or someone's account in India. This is how things flows when you transfer, when you do an overseas transfer. When you carefully observe, there is a lot of third parties or centralized authority. So there is Bank of America, there is Federal Reserve, again it's a centralized authority, there is Reserve Bank of India, there is a centralized authority, okay, and State Bank of India. So what happens is, today, suppose we can say this Indian national rupee rate is 65. 65 is the price for today. What Bank of America will tell you is, we will give you only 64 rupees because we are doing all this headache of transferring between banks. Okay, and finally it has to reach State Bank of India. And only way is, I would give you only 64 rupees. Then Pranav has no choice. He'll have to live with 64. So by this, what he is losing is, he is losing 10,000 bucks. So 10,000 into 65 becomes 65,000. Now he is losing 10,000 when he transfers. Like this is 64. And also it takes time. Okay, now maybe you're using Zoom or some service which is fast, but they have their own business model. Okay, but ideally it takes time for you to deposit some currency from overseas to India, and also you are paying a significant amount of fees. We have lost some amount, right? So likewise, if you look at the entire remittance market or overseas transaction, it is close to $20 billion, I believe. On a yearly, this transaction fees and other thing is almost close to $20 billion. And people are thinking, if we use blockchain technology, this $20 billion could be given for some poor welfare or something better which could help the world. Okay, why we should charge so much amount of fees? So we'll look into that. Okay, so that is how the current system works. Okay, here what they have mentioned is trade is recorded. So Pranav is making it, they're maintaining it and they're sending it. So what are the problems with the current system? So first thing is fees. You are paying a substantial amount of fees, and central authority has a control. So if they decide 65 rupees to give you, they can give 65. Tomorrow they decide of 60 rupees, then you'll have to pay 60 rupees. There is no other choice. Unless you fly from US to India and give some amount, otherwise there is no choice. And also you are not allowed to transfer a small amount. Say if you want to transfer just $1 to India, that is not possible. Even for charity, just imagine that for a charity purpose, you want to contribute $1. So everyone would like to contribute, right? Suppose when it is $1,000, we might think for $1, everybody will be ready, $1 or even $10. But such kind of transactions is not possible with the current centralized system. And possible solution, what we are going to look at is, if there is no middleman, if there is no centralized authority, today Pratik wants to send something to Hussein. Okay, how can he do that? Okay, is there a way, is there a channel, is there a mechanism where we can transfer some amount of funds directly without using central banks? There is solution. Okay, so that is nothing but why this Bitcoin was created in the first place. So without any central authority, one can transfer funds from one place to another place or one person to another person without a middleman. Okay, it doesn't matter if it is from States to India, or it doesn't matter if it is from you're transferring to your neighbor. It is all going to work the same. If you're going to transfer some money to the next house person, that is also same. It is equivalent to doing an overseas transfer. Both are one and the same. Now we will see how the system, okay, when we say decentralized, you might have questions like, okay, in the centralized, people know that how much Pratik is initiating a transaction. Pratik knows, or the bank knows Pratik, how much Pratik owns, who he is transferring to, and all those transfer process, central authority take care. Okay, when you say decentralized and when you say Bitcoin, okay, who is taking this responsibility? Who is sending funds from one location to another location? We will see that in depth now. So there are three types of system. One is a centralized system. Just think of this as Bank of America. All of the users have account with this Bank of America, and if they want to do anything, if they want to send that funds to the neighbor or someone, they always need to go via Bank of America, and Bank of America only will talk to the outside world. Okay, so this is a typical centralized system. So next is a decentralized system. Decentralized is nothing but partially there is one central authority, and then this one person is talking to another person. Okay, like here, this central authority talks to another central authority. Likewise here. So this is a decentralized system. So the last one is distributed system. So distributed is everyone talks to everyone. So all of them are connected somehow. For this, to understand this, Bitcoin. So now what is Bitcoin uses? Bitcoin uses distributed network. And there are some special peers who are validating the transactions. We will see that. But Bitcoin is a distributed network. For this, I'll give you an analogy. Let's rewind some time back. Okay, let's go to 2000s and let us understand the centralized system and decentralized system too. Previously, if you want to download an audio file, what you do, probably early 2000s or not even early 2000s, in 2000s or 1998, something like that. Okay. So at that time, what you would do is one would go type in abc.com and he will look for the songs, what all songs he has got, the website got, and then you click a download button and you wait until it gets downloaded and then you play the song. Similarly, if you want to download the movie, it's the same. Okay, you go to some centralized website, you click that, it gets downloaded. You see the problem here, it is a centralized system. If abc.com goes down, there is no way that you could download a song. There is no possibility at all. Because it is centralized system, you are just believing abc.com. Then came in early 2000s or I think 2004, something like that, Then came this torrent revolution. So how this torrent works, I know that most of you might be knowing torrent. Let's say that there are three parties XYZ. So XYZ wants to download a song. Let's say that it's a rhymes. X person has this nursery rhyme. He has first downloaded. Okay, next what happens is, let's take 4%. So now Y also is downloading. Y, what happens is Y will download from X. Now, so both of them have nursery rhymes in their respective machines. So it is not in any centralized location. Okay, it is not put in abc.com. Instead, it is residing in their own machine. Now Z wants to download a song. The same rhymes he wants to download. While doing so, what he will do is initially, he will try to do is, he will contact the maximum number of peers. Okay, the software will take care for you. But in turn, behind the scenes, what happens is, it will try connecting multiple peers and then it will download. So let us take this rhymes is 10 MB. Just as a random example, okay, 10 MB. So now the Z system, what it will try is, first 5 MB it will try to download from X, and the remaining 5 MB it will try to download from Y. And put together it will get the rhymes. Now suddenly what happens, Y system goes down, or Y has turned off his system. Still Z is able to download from X machine. So here if you see the SPOF, or single point failure, right? So very good property of blockchain. Okay, so this single point of failure is addressed here. So even if Y goes down, still Z would be able to download from X. And if there are multiple peers, it's well and good, the download would be faster, there will be multiple connections. Whereas in the centralized authority, what happened, it was all abc.com, you just wait for the song to get downloaded from that one particular system. Now we are going to look at pictographically. So you see here there are multiple nodes, there are multiple computers. So let us take the same example. Okay, you have this rhymes. Okay, moment you have, what you do is, you transfer that to this machine and this machine and this machine. It goes on like that, and finally what will happen is, eventually after some time, everyone in the network would have this rhymes. If it is a compulsion, okay, rhymes is nothing, audio file, if you want you would download. But in terms of blockchain, what happens is, the entire set of transactions, let us take Sandeep makes 10 transactions. Okay, in blockchain world, what would happen is, this 10 transaction, it will go here, it will go here, it will go. Eventually what will happen is, after some time, everybody in the network will have all the transaction that was ever made. So if this system wants to look in for the transactions, like what happened in block number 5, it need not go and fetch the information from this system. Instead, it will have its own copy. Distributed ledger technologies. There are two things which are going on in the market. One is blockchain, and other thing is called distributed ledger. So people say that, why should I have a block? I can have only transactions. I don't need a block. All I need is just a proof that I have transacted. So there are some groups going on. So these are some of the industry consortiums. That is, these are a group of people who work on a common goal. So this Hyperledger is one such consortium. They are trying to build a blockchain platform for enterprise use case scenario, enterprise. And in Hyperledger, it is actually open foundation, and there are multiple projects which are going under Hyperledger. So one is called Hyperledger Fabric, which is incubated by IBM initially. Then the next one is Hyperledger Sawtooth Lake, which is incubated by Intel. There is Hyperledger Iroha. There are a lot of projects. So each one is taking a piece of this and working. Okay, so this is that type of a consortium. The next consortium is R3 Corda. So this consortium is nothing but they work on financial use cases. So they are trying to build a blockchain platform specifically for financial and capital markets industry. And the last one is PTDL. This, they are working for trade related use cases. They are trying to build a blockchain system, or they are coming with, they need not even build a new blockchain system. They will bring in the auditors. They will see like what can be done. Okay, how this is going to work in my line of business. So these are some of the groups they're working. And some of the platforms you can see, some popular platforms is Ripple. Okay, whatever I said, Intel, Sawtooth Lake, and Tendermint. You can see Ethereum here. So these consortium takes these all platforms and they're trying to find out what can be used. Ethereum, Bitcoin, like that. And underlying infrastructure, you can have it in a cloud. Okay, you can have your own data center, or you can set up your own blockchain network within your company. You're allowed to do that. Or if you want to go to a cloud approach, that is also possible. So these are some of the options available. So initiating a transaction in a network. So what they're saying is, just imagine there is no central authority, there is no banks. Just imagine today's world, in US or India, you don't have banks, and you want to transfer or you want to send some funds. Okay, Hussein want to send some funds to India. The only way is you physically have some dollars, go convert in exchange, bring the rupee, give it to the concerned person, or you give it to some person who is going to India, some third party agent. That is physically you'll have to go and give the funds. That is the only way. Otherwise, it's all through central authority. We'll see like how this is happening in Bitcoin world. What is this transaction? Who will verify this transaction? What happens? So all these questions you might have thought about. Now we'll see like one by one, we'll address all those questions. So first step is initiating a transaction. Okay. So the important piece of it is, so I'll go here and then I'll come back to the previous slide. So this entire Bitcoin or blockchain, this all works based out of public key, private key algorithm. Okay, you might heard of this RSA key and all, right? RSA encryption standards. It all works using public key and private key cryptography. Let's see like what is public and private key. So public key, private key itself is a very big module. Okay, now what we are going to see is a high level understanding of what it is. So what happens is, there are different encryption standards by which you can create this pair of keys. Okay, normally what happens when you request for this encryption mechanism, right? You get pair of keys. One is a public key, that is like your house address, you can give it to anyone. Another one is a private key which you will have to safeguard, or otherwise you can correlate with your house key. So you normally what you do is you give your home address to everybody so that they can post, they can send letters or greetings, something like that. And only you can open the door and take what is present there. So that is nothing but private key. So this private key also will be some kind of numbers. So this is how it looks, some jumbled numbers kind of. So the idea is, if you want to send a message, hello, okay, X person, let's take Bob and Alice. Bob wants to send message hello to Alice. Now, what happens in the physical network, if you send some intruder, what they can do is they can go find out what you have sent. So say hello is okay, but say it is a bank account, some kind of information, then it is a problem. So one solution was, first level was encryption. So encryption, when we think simple, shift by one, basic college level, what we do, we shift every bit by one, something like that. You know, you create a hello. Now what you're doing is you will shift everything by one, shift by one alphabet. So likewise, this gets shifted. Similarly, what happens, the recipient should know that what is the key, and then he should pre-shift, post-shift and pre-shift. He'll have to do to get the message. But this has a problem. First problem is you are sharing the key, like what is that you want to, and the key is very weak. You are shifting by some characters which will be easily identified. So the concept here is public key and private key. What if Bob wants to send a hello message, what he would do is he would get Alice public key. Everyone will be having a pair of keys, public key and private. Alice would be sharing her public key. This is Alice public key. Now Bob will, what he will do is he would take Alice public key and then he will encrypt this hello message, then send it to Alice. Okay, now only Alice can open this message with her private key. No one will be able to open it. It is not possible at all that only who has this private key can open the message. Okay, now in this case, Alice is using the private key, whatever she has, and she is opening the message. I would recommend, I have a post here. There is something called cryptography basics. Here I have mentioned like how do you create a digital signature, how do you get a pair of keys, and how to encrypt, decrypt. I've given this hello Alice example. I've given step by step if you want to deep dive into cryptography, like basics if you want to go through. So now here what happens is, here James is trying to initiating a transaction. James uses two pieces of information, that is his public key and private key. So now what happens here is James is trying to send some funds to Kevin. He's like our hello message. He is taking Kevin's public key and then he's encrypting. And only who can open? Decrypt, only Kevin can open using his private key. Any other private key will not be allowed. Just remember this house analogy, like you have your home address which you can give to anyone, but only whatever post or envelopes which are sent, only you can open because you have the private key with you. So there is another version of it. Okay, so here what we have seen is we have taken the public key and encrypting, right? So in the Alice Bob case, so there is one more case. Okay, suppose what you are doing is Bob is sending a marriage invitation or something like that. Okay, so what he is doing is he is encrypting with his private key and he is broadcasting the message. Whoever has Bob's public key can decrypt. It's vice versa. Bob has encrypted using his private key. So Alice needs to know Bob's public key to open it. Just go through that link. It has examples, and also like if you want to try out, there are commands also to try out. So the concept is encryption. Encryption is used for sending any transactions. Especially, right, I would spend a lot of time here public key cryptography, not now, but maybe after 2-3 weeks. If you want to get into this blockchain, especially when you look at this hyperledger fabric, it is all SSL certification, HTTPS, it's all works like that. Okay, so I would recommend all of you to go through it completely and understand cryptography concepts. So where are the keys stored? Keys in the Bitcoin world, it's stored in the wallet. Okay, we'll see what it is. So normally what happens is, so we have this Bitcoin address and wallet. So it is nothing but, now let us focus our shift to Bitcoin. Okay, so you want to make some transactions. High level, you have understood what is blockchain. So Bitcoin uses blockchain as a technology to do all the transactions. So for normally in a Bank of America, if you want to have an account, what you have an account number, you log into Bank of America, and then probably you have a password, and then you get in and you do some transaction. Similarly, here you have something called wallet. So this wallet could be of different types. This wallet always comes with two elements. One is a public key and private key. So private key you would be signing if you want to send a transaction. Suppose the previous example, James want to send something to Kevin. He takes Kevin's public key and then sends the transaction. So you always get a pair of keys. Public key, you see, you can look at here. This Bitcoin address is nothing but a public key. Okay, people call this an address. What is your Bitcoin address? It is nothing but a public key. And this is a QR code. So the representation of this one as in form of a QR code. And if you want to send some transaction, you need to enter your private key. And that is like your password. You cannot simply go and send a transaction. You need to prove that you are, for this public key, you have a private key. So you get always like a username and password. You get this couple of things. Now let me quickly go and show you like some of. This is nothing but a blockchain info for Bitcoin. It will have entire all the blocks which were ever created. You can see here. So let me open a block. Inside the block, there are a lot of transactions which have happened. So you can see that some numbers to some numbers here. And you can see some Bitcoins have been transferred also. So this is nothing but the public key. See here you can see Bitcoin address. So this has an address, this has a QR code and things like that, right? So this is nothing but the public key. And with that you have a private key that will not be shown here because that is going to be your secret. So that is your private. So we will look into this blockchain. We will see like blockchain.info, what are the information we have here. We will see in the subsequent slides. For now, understand that this is how an address will be look like. So that's what they have mentioned here. Bitcoin wallet types. So there are different types of wallet. As I mentioned in the third module, we have a lot of information about wallets. So these are different types of Bitcoin wallets. First one is hardware wallet. Hardware wallet is all these wallets, whether it be software, whether it be web, cold or hardware, everywhere you get the pair of keys. Hardware wallet, what happens? You get a pair of keys and you can store the Bitcoin here. You can have the password or the private key separately noted down in a paper or something. So your Bitcoin physically will be present here. So now if you want to transfer, you can transfer from the hardware wallet. Cold wallet is you can have it in a, that is you're not cold when we say like how we say, right, database is in cold. Likewise, so it is not connected to the internet. So you store it in your Bitcoin, whatever Bitcoin you have, right? You can store that in a piece of USB drive, or you can note down your public key, private key in a piece of paper. So that is nothing but cold wallets. Web wallets is nothing but if you are trading via exchange, okay, you are buying Bitcoins and selling Bitcoins over exchange. What they do is on behalf of you, they maintain your public key and private key. Even though it is risky, they maintain it, but still for trading purpose, we leave it there. These are web wallets. Software wallets are nothing but you can download a piece of software which would generate to you a public key and private key, which will sync with blockchain. It will do all those functionalities. Okay. So these are software wallets. So now we'll see like the transaction, how things are happening. So here what happens is whenever you send a transaction, okay, in the Bitcoin world, you have a public key, private key. In Bitcoin world, what happens is maximum you sending some funds to some person. So whether it be in India or anywhere, all you need to know is the persons, okay, whom you're trying to send, you need his Bitcoin address or public key. Both are one and the same. Okay, you need to have that. Once you do that, have his key, you are saying, say, if you want Kevin, in this case, Kevin is sending James 5 Bitcoin, okay, and he would enter his private key. Then what happens? A transaction is initiated. So whenever it's initiated, it goes as a like this. It will be gone as a digest message. It will be a digital signature. That is nothing but previous example we have seen, right? Bob is sending a hello message to Alice. When it is signed, what will happen is it will all have a jumbled numbers. That's how things looks like. But inside the jumbled numbers, there is hello message. So that only who has private key would be able to decrypt it. So that's how every transaction goes. All you need to understand is someone's public key would be taken and across that funds would be transferred. Now, next, let's see how the transaction propagates. How is the transaction faster than the present system? So in a distributed architecture, okay, how things works is you send a transaction, any message, anything you try to broadcast, right? What happens? It goes here, it goes here. Every node will propagate its information to the next node. Sometimes in Ethereum world, it's called gossip protocol. Moment something happens, the information is gossiped to the next node. So that's how it is passed, and that's why it will be very fast. So normally in the traditional system, what happens? See, there also internally, if you look, it is happening the same. Okay, suppose this is a abc.com, and if you want to download the file, what will happen is it will go through multiple routers. Like it will not go via peers, but it will go via router switches, and then it will take the information and then it will give you. That's how it works. Here it is more of a peer-to-peer fashion. So if this peer has information, immediately you get it. That's about it. So next is who validates, since there is no central authority. So there are the special nodes called miners. So this miner's responsibility is to validate these transactions, whatever transaction, right? So in the previous case, what we have seen is person A has sent some 10 Bitcoins to Pranav. So that validation, who is validating that, we will see in the subsequent slides. Mining is a process. It is nothing but in a traditional banking world, what happens when you transfer funds from Bank of America to India, there are central authorities who are verifying that such a transaction has taken place. Likewise, in the decentralized network, someone has to verify that such a transaction has taken place. So that is what the miner's job is. So how to verify this transaction, who is verifying it, I'll let you know all those things. So I'll use my notepad for explaining. So this is a very important concept. So let's first, what is happening is there are many nodes in the network like A, B, C, or Tom, Harry. Lot of people are in the network. Everyone has this public key, private key. All of them have this addresses with them. First step, everyone has a public key and private key. And first, let us take a simple transaction. The transaction is A is sending 10 Bitcoins to Harry. So what happens here is A has to know Harry's public address. Only then he would be able to send a transaction. And also A will be having his private key. He has to sign his transaction using his private key. So this is the first step. Step 1, A has to know Harry's public key, and also he has to have his private key to send a transaction. So this is how a transaction is initiated. Now, moment a transaction is initiated, what happens? We looked at that diagram, right? So there were a lot of nodes which were interconnected. So the transaction goes to A to B system, then it goes to adjacent nodes. It gets propagated like that. So B, what will happen is, see, suppose A has sent a faulty transaction. Let us say A does not have 10 Bitcoins at all. A is having only 1 Bitcoin, but A is trying to send 10 Bitcoins to Harry. Then if node B is going to propagate this information to everyone, then it is a problem, right? The transaction which is sent, does not have any meaning at all because it is a faulty transaction, and that gets propagated to everyone, which is waste of time. So there are some certain steps. Each step we will look deeply in the third class. For now, what you understand is if a transaction is sent from A to B, some validation will be done by B before propagating it to Tom. Tom will do some validation and propagate to Harry. Okay, in case if B finds out that transaction is invalid, he would reject that transaction. Before it traverses from one node to another, okay, each of the transactions are minimally verified. There are some verification steps and it will be verified. So that is the step. Here I have mentioned Tom to Charlie. So here what I'm saying is Tom to Charlie it goes and peer node validates up these transactions. They are doing some basic checks. So now this is how all these transactions are initiated by every node. Now what will happen is there are some special nodes called miners. So they will validate all these transactions. So mining is a process of validating that transaction and forming a block. Let us see. So there are some transactions coming, okay, like transaction 1, A to B, A is sending to B, B is sending to C, Ram is sending to Sita, like that. The lot of transaction keeps on happening, transaction. This special nodes, mining process, okay, these are mining nodes. There will be many mining nodes in the network. Let us take mining node 1, 2, there are many mining nodes. Their job is, they will pick up the transaction. They will pick up all these unconfirmed transactions. I'll come to what is unconfirmed transactions. So that is unconfirmed transaction, nothing but this transaction should not be there in any of the previous blockchain before, not blockchain, block. So now job of the miner is nothing but one computer system. Just imagine like that. Miner is one computer system. He will be waiting for the transactions to come. Moment he gets some amount of transactions, like suppose say like our block size is 1 MB, okay, or 2 MB, and 1 MB can fit, example, 100 transactions. Real world it is more than that, but I'm just throwing an example. So 1 MB is trying to find out all the 100 transactions. Now I have got 100 transactions, so I made sure these are unconfirmed transactions and basic validation is done. And another thing is, I would also make sure that person A has this much amount of money. So all this has also been validated. Now I'm going to validate this block of transactions and then create a block. Okay, so miner's job is take this 100 transactions and add it to the blocks. Previously in the first few slides we have seen, right? So there was a genesis block and block after block, there were a lot of blocks. So miner is trying to validate these transactions. Once he is successful, he will add that to the block and add it to the chain. This is theoretically. I will explain how the puzzle works. Before this mining piece, this solving the puzzle, I will show you like how the block looks like. So you will get an idea, then we'll go deep dive into it. So I'm going to blockchain.info and this is the real Bitcoin network. Here I'm going to search the first block ever created. So this is block 0, or it is called Genesis block, and it has one transaction out of, it has output of 50 Bitcoins and there is only one transaction. Now let us look at 10,000th block. Okay, in the 10,000th block also there was only less transaction. Maybe we should look at the latest one. So let us look at block which was created before 25 minutes. So I'm clicking this. So here totally if you see these are the important things which I want you to observe. Okay, in this block, how many transactions has happened? 2,358 transactions has happened. So these many, and how much Bitcoin worth was transferred? It is close to 31,000 Bitcoins. And you can see these are those 2,300 transactions which has happened. Okay, all these transactions which happened before 25 minutes. So what I want you to notice, so there is 3,300 transactions. Some transaction has happened. These are the transactions. And if you see, each block is tied with the previous block. You see here, this is the previous block. And each block has a hash. So that also we'll see what it is. So it is nothing but with all these transactions and everything, it generates a hash. And what I want you to look at is, there is something called difficulty. How difficult was to solve this puzzle? And what is the reward I'm going to get if I solve the puzzle? Okay, it is 12.5 Bitcoin. Okay, and there is a nonce. This is a very important number, nonce. So now let me get into the details. Now let's go to the puzzle, like how it is getting solved. This is the puzzle we are going to solve. Okay, every miner in the network has to solve this puzzle. It is nothing but what it has to solve is, So this is nonce or a number, okay, random generated. So with all these transactions, right, with the 3000 transactions, our example have 3000 transaction. Out of this transaction, you generate a hash out of it. The software itself will generate for you. So it will generate a hash number. This is nothing but the challenge string. Okay, next comes the difficulty. So network will tell you, you add a number with this and you do a hash of it. If you do a hash of these both, I need a result of 42 zeros prefixed. 42 zeros. Okay, let me go here. See here, I have written it. So we have this challenge string, and all we are going to find is we are going to guess the number, and what the puzzle says is whatever number you take this challenge string and you add any number to it, and when you do a hash, all I need is I need prefix of these many zeros. If you find these many zeros, then I agree that you have solved the puzzle. That is proof of work algorithm. What it says is challenge string is nothing but the hash, whatever number you want you choose, but the riddle says get me 42 prefix number of zeros. Now miner, what he has to do is he will start from 1. There is no other way to do it. What he does is he adds number 1. Challenge is nothing but the hash. Okay, number 1, and with number 1 he tries to add the hash and then get the hash, and then he will check whether I have received 42 zeros. Then he will repeat. Now I take the number 2, add it with the challenge string, I hash it whether I get 42 zeros. Likewise, miner has to try indefinitely until he comes up with this 42 zeros prefixed. The 42 zeros is nothing but the difficulty factor. So tomorrow, if the difficulty level has to be increased, just a number, one more difficulty level, if it is 43 zeros, it will be like 1 trillion calculations per second. So this has to be done continuously, and then the riddle has to be found. Once this, suppose let's say this miner has found this riddle. Yes, our nonce number is 89, just a random example. You have a challenge number with 89, you found a number which has a prefix of 42 zeros. It means you have won the puzzle. Means like for the block you are trying to mine, you have found the puzzle. Now what you would do is you would propagate your block to other miners to validate. Now other miners would validate whether the block you have solved is right. If you have solved it right, you get a reward of 12.5 bitcoins. Miner would get a reward of 12.5 bitcoins. Make sense? And also this block will add it to the blockchain, meaning this block or this entire amount of transactions in the block is being validated by the entire network, and it is foolproof. It can be added to the chain. So what happens is once the transaction is verified, right? This is an example. Here what they've said is once the transaction is, the block is validated, what will happen is this block will be propagated to all the peer nodes. That is nothing but the ledger. Here what they have mentioned is, so James has $10, okay? And in fact, this is a typo actually. So all the transaction, James is transferring $5, okay, it has to be 5. Okay, and Kevin to Paul 3, all the transaction which has ever happened, right? It does not go to centralized. Instead, what is happening is it is stored in all the nodes. So James knows what all the transaction has ever happened. Robert knows what all has happened. So this is what they are trying to depict. Next one is ordering of transactions. We'll see this. So the question comes like, suppose A has only 10 bitcoins and A is transferring Charlie 5 bitcoins, or we'll say 10 bitcoins only. Okay, 10 to Charlie. At the same time, A is also transferring to Tom 10 bitcoins. He's trying to fake. So at that time, what happens is only one transaction has to go through. So other transaction should not get passed. Okay, suppose let's say this transaction he has initiated from India, and okay, he is opening the same wallet somewhere else in US, and then he's trying to transact. Then what happens? Say USA and India. So wallet address is same. Someone is opening A's wallet from USA and sending 10 bitcoins to Charlie. And someone is using the same A's wallet, opening in India, and they are trying to send 10 bitcoins to Alice. So now, just I have taken a USA and India just to geographically, I just want to assume that it is a very far, but eventually it's not going to happen like that. Okay. So 2 transactions got initiated. This is on transaction, this is on transaction. then what will happen is it will all get propagated and then it's going to be formed as a block. So at that time, one transaction would go through, one will not go through. So that's when this order and everything matters. Okay, one transaction will go through, one will fail. So by that way, we are eliminating that A is not sending a double spending. So this is how you see block number 145 followed by 146, 147, 48. This is how these all blocks has a block hash, block ID. We have seen, right? Each will have a hash number. So this is a hash number. This previous block is tied 145th block, right? You see 146 will have this block ID, previous block. So this one will have this block's ID. Similarly, that's how everything is getting chained, chain of blocks. Now there is a scenario that there is an Indian miner. This is also I am considering geographically. USA there is a miner. Similarly, in India there is another miner. So they are also waiting for transactions to be mined. Okay, so he has taken 3,000 transactions. Similarly, he has taken some transactions, and they are both trying to mine the block. Let's say that both of them have mined the block. He was able to do it in say 6 minutes. He was able to do it in 6 minutes 1 second, like that. Okay, like that they were able to mine. So now we have two blocks which are under race. Instead of race, I would say like there are two blocks which mined. Who will get the reward? What will happen? What happens is, moment your block is mined, you will not immediately get the reward. You will get the reward only after miner propagates the block into the network. All other miners have to validate whether this block was mined successfully. Then only the 12.5 bitcoins will be awarded as a reward. Now in this case, what will happen is there are two blocks. For instance, let us take both are been mined in the exact 6 minutes. Then what will happen is two chains will be propagating for some time. That is, let us say we have block 1, 2, 3, 4, 5th. We are supposed to add the 5th block. Then what will happen is in USA side, people will be adding block 5 and they will be going. This block came from US. Another, what will happen is in India, they think like, this person has mined. Okay, and they will try to add Indian block. Okay. Likewise, two blocks goes, but the 12.5 rewards are not allocated yet. What they will do is, since now there is a problem, right? So both are them in the same height. They will see there are other miners nodes will validate, okay, who has done most difficulty rate, who has solved most difficulty rate, or who has solved more number of transactions. In this case, so let's say both are 3,000 transactions. Both have same difficulty rate, 42 zeros. Both have same minutes. In that case, what will happen is, they'll see who is adding the next block here, right? So suppose there is one block which gets added here in the Indian chain, right? Here it's not getting added, it's taking some time. Then what will happen is this becomes the longest chain and people will start following this chain rather than the Indian chain, and the reward would go to this miner who has mined this block. You see here there are list of transactions. So these transactions are all initially validated by basic validation is done by the peers. Okay, now once it is in the block and confirmed, it means that it is a tamper-proof record that yes, such a transaction has happened. And you can see this unconfirmed transactions are there in a pool. And for forming a new block, these transactions are pulled in and then the puzzle would be solved. So here you see this is the existing blockchain. Now there are two new blocks. Okay, one miner from India. So here they have said Lisa, okay, and Paul. If you consider miner from India and miner from US, so they are trying to mine a block. In that case, who would be the winner? So that is the question. We'll see that. Whose block to consider? If there is exactly same in that case, whose block to consider? And here, so proof of work, block puzzle. Okay, so it takes, whatever we have seen, right? So they have given it in text. Probably I think I've explained to you like, what are those zeros, how it works. The important thing to notice here is mining this proof of work algorithm, right? It takes a lot of electricity. What they compare it with is the entire Bitcoin network takes or requires electricity of Iceland. So the entire Iceland's electricity power is required for running a Bitcoin network. So that much of electricity is required. Why that much of electricity is required? Because the puzzles which you are trying to run is trillions of calculations per second you are trying to do. So that much of processing power it requires, and here comes the electricity. So that's why electricity is more, and part of Bitcoin solution that each contain answer to a special math problem. Math problem is nothing but the zeros. So there are three components. Okay, so we have seen this already. So nonce is nothing but your answer, the random number which you are trying to find out. So that is nonce. So hash is nothing but every block. Once you frame a block, you can hash certain elements and create your block hash or block identity. And transactions, whatever transactions which have happened for that particular block, whatever you are choosing. So finding the puzzle, why it is hard? Because it is brute force. So there is no direct solution to find out the puzzle. You'll have to try with all the random numbers. So roughly it takes around 10 minutes for one to find the solution. So what if one builds a lot of processing power and is able to solve in 6 minutes or 5 minutes? What happens is blockchain or a Bitcoin network, it is defined in the Bitcoin protocol. Bitcoin protocol will monitor how fast miner is able to solve the puzzle. If it finds that people are solving the puzzle so quickly, then the difficulty rate will be automatically adjusted. From 42 zeros, it will be 43 zeros. For 1 zeros, it is like 2 power 42. It is a drastic. So it is like multiplying into 2. So that much amount of work one has to do to find again. So suppose next time onwards, once the difficulty level is increased and now the mining takes place or the 11 minutes or 15 minutes, then accordingly the protocol itself will adjust the difficulty rate. So this difficulty rate adjustment is happening every 2 weeks once. So that is also defined as part of Bitcoin protocol. It roughly the difficulty factor will be adjusted every 2 weeks once. So there is some calculations like number of blocks exactly. Based on that, the difficulty factor would be adjusted. So now we'll touch base on some security properties of a hash function. So hash function, I've shared an article, and also there are some very important properties of hash. So hash is nothing but a mathematical function. So for example, if you guys have from programming background, you would know that we talk about classes and objects, right? So each object is a hash. If you go into internals, so each one is a hash. This hash algorithm should have certain properties. Okay, we'll see what are the properties. First one is collision free, meaning, so if you give an input as Alice, okay, and if you want a hash, you get an output, and no two inputs will have the same hash. So Alice gets a hash, Bob will have a different hash, Charlie will have a different hash. No two inputs will have a same hash, even if there is a smallest change. In Alice, you keep a just full stop, then you run a hash function, the output would be completely different. So that's what, if you look at the article which I've shared, there are some steps I have done. So in that I've showed, like, if you have a period, the entire hash output would be different. So just try that. So this is the first property, collision free. So the next property is hiding. That is, say for a given input, you get an output which is completely not relevant to the input. So if you give Alice as an input, you get an output completely some gibberish numbers. From the gibberish numbers, you would not be able to make out what the input was. Okay, so that is the second property. And the third one is puzzle friendly. So it is nothing but your hash, you should not append with something and you get an input back. So likewise, it should not be there. So these are the properties of hash you should just keep in mind. So why do miners invest in their resources in validation? So why do they spend so much electricity? The reason being they are getting a reward. So they're getting a reward of 12.5 Bitcoins today. So these are miners' reward. What do they get? They're solving the puzzle. So they are trying to find the answer. One who wins publishes to the block to the network. Okay. Once publishing or broadcasting, what happens? It will be validated, and other miners would take this. They will come to a consensus whether this block is a valid block, and then they will add it to the blockchain. So the reward, they spend so much of electricity and they're trying to validate all the transaction in the network. So they are rewarded with 12.5 Bitcoins for now. So that is the monetary reward they get. So next is, how is the currency generated? So currency, what happens is, see the limit of 21 million Bitcoins, which we have spoken some time back. So this 21 million Bitcoins is already hardware, meaning that it's already mentioned as part of the protocol. And every 10 minutes once, a reward will be generated and sent to the network. Okay, so this they have represented pictographically. So this is the blockchain. And what happens is there are a lot of transactions inside a block. So there is a challenge string. So challenge string is nothing but the hash which is generated. And then you're trying to prove it. Proof is nothing but the nonce. Okay, so the random number. And you are doing a hash of it. And once done, what happens is it gives you an output with so many zeros in front. So this zeros defines the difficulty factor. Once done, the winning block is added to the blockchain. So next one is if what happens. So these are all things we have seen. If more than one block gets solved in the same time, what is happening? So that is solved using consensus mechanism. Let us see what happens. Now consensus algorithm. So what is consensus algorithm? We'll just look at that and then we'll see what happens when both the blocks gets mined in the same time. So for any blockchain or any consensus is just a common word, just coming into an agreement. So there is a special rules which are set up saying that if X happens, do we all agree? So something like that. Let us take a simple example. Okay, so we all suppose a group of people are living in an apartment, and what they decide is if something goes wrong with the swimming pool, all of us has to contribute to the pool. So whatever may be the amount, or maybe they have some nominal amount, say maximum we could contribute $5,000. This is nothing but they are framing a rule, upfront before something happens, they are framing and everyone agrees to that. Tomorrow if something happens to the pool, it's already agreed. So that becomes consensus algorithm. So here, what is the consensus here we are talking about is, so what if two blocks are solved in the same time? Then who would win? Okay, so all those are defined before. Suppose I'll give you another example. Okay, let's say that running race is happening. This may be a weird example. So let's say that a running race is happening for a group of 10 people. So the idea is if two persons are coming at the same time, in that case, what would happen is we will look at their previous track records, like till final, whatever was their points, how fast they have run. Based on that, winner would be awarded. This is assumed before, or the committee members have come to a consensus that if two persons are winning the race at the same time, the previous race would be considered. So that is agreed. Now running race happens, two persons are coming at the same time. Then based on the previous rules which are defined, person would be chosen as a winner. So this is consensus. So here they have similarly in Bitcoin network. So in what all scenarios, those we'll look at, like what happens when the next block is solved. So here what happens, the previous Paul's blockchain. So what happens here is Paul's blockchain, nothing got added. Here there is one more thing. But if you see here in the Lisa's blockchain, there are how many blocks? 1, 2, 3, 4, 5. But here the Paul's blockchain or Robert's blockchain, what happens is maximum they have only 4 nodes. 1, 2, 3, 4. So here what happens, even though they all solved in the same time, after a while, after a period of time, this branch or this Lisa's blockchain seems like she has more number of blocks. Now what happens, everyone would, all the other participants, right, other blockchain, this is a consensus. So yes, okay, you all solve the block in the same time, you continue to solve, consistently wins the race. Then what happens is over a period of time, Lisa's blockchain, okay, has more number of blocks, and everyone, like other networks also would follow the chain because Lisa has more number of blocks. So they're trying to adapt to the longest chain. So once they adapt to the longest chain, what happens is this block, right, all the blocks which got solved before, this goes to the unconfirmed transactions. So in this case, the orange and the green block, it won't get rewarded, and as well it will be put into the pool of unconfirmed transactions. So what if a miner is trying to cheat the system? So this one we'll see like what are the negative scenarios. Let us go to Notepad. Okay, cheating scenarios let us take. So in India, USA, okay, suppose these are transactions happening. So AB is one transaction and a transaction. So now if suppose A in India, a miner is trying to add a transaction A to D, AD, which has not happened at all. Then what happens? This one, right, this block goes to the other miner nodes for consensus. At that time, they will be able to find out whether such a transaction ever did it exist or is it a fault transaction. Okay, so by that way, they will be able to eliminate such a block. Okay, so this is one thing. So the next one is, this is one type of attack. So that is theoretically speaking, it is just for the sake of theory. Theoretically, Bitcoin can be hacked. When we say hack, we can attack the Bitcoin network. How is, so let us take here, what is the mining ground rule? Mining ground rule is one has to solve the puzzle and then the transaction has to be validated. The mining block has to be validated by other miners. Suppose, let us take in India, there are 10 miners. First block contains AB transaction. In second block, They are adding AC transaction, which did not happen at all. And similarly, AD, like that they are trying to manipulate. If one has to manipulate like that, what should happen? They should add a block, and that has to be confirmed by other miners. That's 6 confirmation. Theoretically, what they are saying is, in India, there are other 6 superpower miners. As soon as the transaction is done, the other miners are going to confirm. It will go on like that. So theoretically, it is possible. But practically, what is happening is, one needs lot of power, lot of electricity, lot of hashing power to build such a system to hack the network. And what they're saying is, in the world, there are like couple of supercomputers. Okay, even if you build 10 times such supercomputers, you will not be able to hack. You will not have that much of enormous power because it is distributed. The power is distributed now. So you will not have such a power, and henceforth, practically, it is not possible. But theoretically, on papers, yes, this hypothetical scenario exists. And another thing to notice is there are some pundits or gurus, what they are claiming is the next age of computing, right? What is it called? Cognitive computing or quantum computing. Once this quantum computing comes into picture, it would be easy. That's what the one set of people are arguing. Pictographically, they have represented bundle transactions, verify if transactions are valid, solve the proof of work. When the solution is found, the block propagated to the network. What if someone tries to hack the system? What happens is, suppose one miner is trying to add a block with all faulty transactions. Moment he is trying to add, what will happen? First of all, other miners would reject. Okay, and if he's trying to add the hash, okay, he should know the previous hash. So by that way, basically others would reject and it will not be able to, not possible. If there is a faulty miner, in consensus, it would fail. So there is no way to alter the system because it's all blockchain. Everyone has the copy. Okay, suddenly if you say that such a transaction has happened, that is not possible. So the protect by raise 51% attack, what I have mentioned. To sum up, distributed or what is happening in the blockchain till now, what we have done is it is all through public-private key, and every information is propagated from peer to peer. And the Bitcoin world, it's all public ledger. Okay, everyone has a copy of it. And the next one is miners are getting validated, and finally the consensus. So benefits of blockchain technology in terms of cryptocurrency, in terms of Bitcoin, what is that you have achieved? Settlement in real time. So in the bank world, what happens is bank will initiate a transfer to you, but behind the scenes, they will work with other banks to get that transfer done. But here settlement is real time. All the ledger would be updated for everyone at the same time. Cost saving, the remittance thing we have seen. Security, it is, even though it is public, it is all governed by very strong cryptographic algorithms which cannot be broken. Immutability, once written, this is a very important property. These are some property, security, all fine. When you go to any blockchain interview, or if you want to something, if you are discussing with your colleague or peer, okay, so one great feature is immutability. So it cannot be, once written in the chain is written, and everyone will have this copy. And user pseudonymity, meaning that there is no account name as such. Okay, all it is gone by as a public key. So no one knows like who you are. So in a nutshell, they have tried to put a use of mathematics to create a secure ledger. This is just some without needing third parties. Anonymity and pseudonymity in cryptocurrency. If you look at Bitcoin, all your addresses are all public keys. You have some numbers. Now what happened some time back in United States, there was some regulation. You all may be knowing about this website called, I think, Silk Road. So where this was in 2012 or 2011, people started using Bitcoins for crime, drug dealing, because it is all anonymous, right? No one knows the address. People just, send Bitcoins to this address and they deliver drugs to you. Some in some fashion. Even they kill people, I heard. So this website, it's called Dark Web. In fact, you can watch the TED video of Dark Web. It's very good. So these websites wouldn't be indexed in Google. So they used something like that, and they were using Bitcoin. And then came this Bitcoin regulation that people or the government started tracking this address belongs to which IP. Previously, such tracking was not there. Now there is something that is getting tracked, like from which machine it got originated. What was the location this transaction? Externally or somewhere, they're trying to track this information in Bitcoin after 2013. So even though we say anonymous, you have public key and other things, still you are able to see, you are able to find out if you go search in the blockchain.info, you will find out from where to where it is sent. Okay, the information from your address to whom you have sent the coins. Now there is a group of team called Zcash. They wanted to eliminate this. What they did is, Bitcoin is pseudonymous. It has some public key. Anonymous is nothing is known. So Zcash used this anonymous concept. Like you send some Bitcoins to X person will not know from where it has come. He will eventually get his Zcash, he will get his cryptocurrency, but he will not know that from where it has come. So those all would be encrypted and sent in the network. So that is Zcash, the one type of cryptocurrency. So this is more of a theory actually. So what all types of cryptocurrency are there? Even there are a lot of other currencies also which is not mentioned here. See, these are some of the anonymous cryptocurrencies. Recently you might have seen this Monero and Dash. I think Dash was all-time high. So let's see, there is a important, like it's a double-edged sword. When you have a complete anonymous cryptocurrency, what they say is a double-edged sword, meaning that, see, people could use for drug trade and things like that. Okay, all corrupt things. At the same time, suppose if you want to deliver some political speech, that's example given here, or some critical message the military general wants to pass it on to someone else, very critical message. In that case, it is very good if it is anonymous, completely anonymous. It is based on case-to-case scenario. So these are some of the cryptocurrencies which uses anonymous concept. And here, so the idea, they are using a protocol like how we are using proof of work algorithm. We will not go deep dive into this ZK snarks algorithm, okay, but I will give an idea like how it is working. This ZK snarks, it is called as zero knowledge proof snarks algorithm. So the idea is, I'll tell you one simple story, that is, it is easy to remember also. The story is like they would be looting the town, okay, in the night time, and they get all the jewels and other things and they dump it in the cave, and then again they go back. That's how it works, right? That is a story. What happens is, moment they come to the cave, okay, they say some secret word and the cave opens and people go and dump the jewels. Okay, so that's how things were, per story. So the ZK snarks algorithm, what it says is, you don't give me the key, but you prove me that you can get into that cave. So for that, what you will have to do, suppose let's say that I know the secret key and I want Prashant to know that I know the secret key, but I should not give my key to Prashant. Okay, so what I can do is I can invite Prashant or make him stand some time back and open it and show him. I won't show the key, but I will open it and show him the proof that yes, I have opened. Okay, and then similarly I will close it and show him that I can close. Okay, but I will not reveal the key. Such an algorithm is this zero knowledge proof algorithm. So in the enterprise world, if you look at Ethereum, right? In the Ethereum world also, they have tried to incorporate this ZK snarks algorithm for sending the transactions. Okay, recently it was launched like a month and a half back when I did not go through completely. Okay, so they were trying to implement this algorithm, ZK snarks algorithm, and this is getting very popular, especially in the enterprise network where they want to hide the transaction between two parties or hide the transaction between competitors. They wanted to go with this algorithm called ZK snarks. Okay, so problem with the anonymous cryptocurrency, we don't know who is backing it. It is not recognized. What if suddenly government says that it is totally anonymous and we want to reject it? So all those things, there is a problem. And pseudonymity, it is a pseudonym. Okay, you have been given another name. Likewise, if you look at Bitcoin, even though you have all public key, there is some, I see for now an IP address is also something, there is an association, and you can track this. If you're sending some money to X person, this can be tracked from where it started to where it ended. So here A's address is a pseudonym, what we have seen actually. From where it started, where it resolved, everything can be found out. For example, sometime back, I think this WannaCry virus, right? So once the WannaCry virus attacked, people were demanding in Bitcoins. If they demand in Bitcoins, they would have asked the Bitcoin address. So if they have given the address, they can track like where all it is passing. If it is a total, for example, if they have asked in a Zcash and they have given some address, and then they would not know that where it has gone. So now we will look at this programmable money, pay some close attention. Now we will see, we are going to see how the smart contracts, how the blockchain is helped the enterprise world or even the public world, how it is working. Especially we'll focusing towards Ethereum now. So the example what they have given is, so there is Alice, there is Bob. Today Alice wants to purchase a car from Bob. And let's say that her criteria is emission test. So if the emission test is passed, Alice is ready to buy the car from Bob. So this is the criteria. Now what happens is, for example, let us say that she is purchasing a car from Amazon, or some online mechanism. She's trying to purchase a car, or eBay or Craigslist, something like that. Okay, let's take Amazon for a simple example. Okay, so Amazon, she's finding the car and car is good. At least the pictures looks good. And what she's asking is, can you do an emission test? Bob takes the car and he does the emission test, okay, and then sends an email copy. And emission test has also passed. Now Alice is sending a fund to Bob, and now what happens? Bob is refusing to send the car. For some reason he says that no, my car is there, breakdown. Okay, I'll send it to you tomorrow. Now there is a problem here. And also, let's take our suppose he's sending the car. Okay, let's say that okay scenario. Bob is sending the car, but emission test he has faked. He did not do the emission test properly, and he has faked, and he has sent to Alice. And Alice now only knows that emission test has failed and Bob has cheated him. So let's see that how blockchain is solving this problem. So in blockchain, what we are doing is, here we are creating something called smart contract. Okay, smart contract is nothing but a piece of code, like how your transaction, like that, a piece of code which will be present in all the machines. Like how your blockchain, all transactions you have, right? Similarly, this piece of smart contract will be present in all the nodes in the network. In the smart contract, what is written? Let's see. Alice, some buy car, only buy car. For buying car, you need to send funds. Suppose let's say that $10,000. Now Bob has to send the car, and also emission test has to pass. So all these functionalities has to be done for a successful transfer of ownership, like the car from Alice to Bob has to do. What all things has to do? First, Alice has to look at the car elsewhere and she has to purchase. She should send some amount. And the condition, what is the condition she is mentioning? Emission test has to be passed. Then if that is the case, he would send and things would be fine. Okay, now what is happening with smart contract scenario is, Alice would be sending, I'll take, instead of dollars, let me take Ether, cryptocurrency for example. Alice would be sending 10,000 Ethers to this smart contract. This is a contract X. Let's say that this is a purchase contract. Now X has funds, and in the contract, what will be the next step? Emission test has to be conducted. So the emission party will come. So Alice, Bob, let us take one more property. Let us take CarZone or some company. Let's take Firestone. So now Firestone, is testing whether the emission test has passed. Once emission test is passed, he updates here that the emission test is passed. Then there is shipment. Okay, someone would be sending the car, right? Then the shipment company makes sure that the emission test is passed, and then he updates that he has shipped. Only then the amount will be sent to Bob. Unless that happens, the amount will be with the contract. Alice has sent to the purchase contract. This 10,000 Ethers, Alice has sent to the contract. Now contracts looks for the emission test is clear, then shipment is cleared, only then the car would be shipped. Suppose in this case, let us take a negative scenario that emission test has failed. Then what will happen? In the contract itself would be defined that emission test is failed, send back the 10,000 Ethers back to Alice. Okay, so this one will be automatically, the contract will send the amount back to Alice. What we have seen is how it can be programmed. The smart contract, how it can be programmed. So this is the Alice Bob car example. So what they're doing. So that is the example I've explained. Is there any other implementation of blockchain? Yes. So that is for smart contracts. That's how it evolved. After Bitcoin, then came Litecoin. Then after that, this one of the Bitcoin core developer named Vitalik, he started this company Ethereum, and that's why the smart contract concepts. So here what they mean is, in monetary aspect is just one piece of it. Thank you all.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!